All right, welcome back. CS fundamentals in Python. We talked about for loops last time, and this time I really want to focus on while loops, which is another kind of loop. For loops, if you remember, we were using primarily when we were iterating over collections of items or when we wanted to iterate by one over a range of some sort. While loops are the kind of loops we're going to use whenever we're waiting for a condition to change. We used it in our guessing game because we wanted to keep looping until the user guessed the correct answer, right? So there was no set number, there was no set collection, there was no set range that we were trying to loop. We were waiting for a condition to change, the condition of the correct answer being guessed. So they typically use Booleans. Also, you have to be careful with while loops because they can result in infinite loops if we're not careful, and we'll look at what that looks like too. So let's jump over to our code here. So we had our little experiment at the end of last time where we were talking about how we might solve the problem of summing all the numbers from 1 to 200. Let's go ahead. I'm going to actually take all this out and just start a new loops at the beginning of the loops file. And this time, remember, we're going to focus on while loops. So let's say we were writing a game, for example, and we had some character whose health was 100, or let's say 10, and then we want to do something different once their health drops far enough. So we could say something like while health is greater than 0, print still alive, right? And then do health minus equals 1. Remembering that minus equals is our iterator that takes 1 away each time. And why don't we go ahead and inside here, we'll make this an F string. And we'll go ahead and print our health. And then after our while loop, let's go ahead and print game over. You have this much health. Build that out a little bit. Okay. Let's go ahead and run. Notice here, let me clear my terminal here so you can see. I am in my virtual environment, right? I've activated my virtual environment and we're ready to go. So let's go ahead and run our loops.py. Still alive, you have 10 health. Still alive, you have 9 health, 8 health, 7 health, 6 health, all the way down to 1. And then you'll notice game over, you have 0 health, right? So this while loop keeps going now. Could we have achieved something similar with a for loop? Possibly, if we knew our range, right? If we knew our range going in was going to be 1 to 10. Absolutely. But what's nice here is other things could happen, right? There could be other parts of the game that restore our health, subtract more health, whatever. It's going to run this check, though, constantly. And when it gets our condition, it'll skip out of the loop. So it's not based on a certain count, right? Lots of other things can happen to affect health, and then this happens. So what if we were interested in, let's say we were interested in when health was equal to 0, and we were going to subtract 2 each time. Let's see what happens to our program. Okay, you'll notice that right away we skip out because this is looking for a equal to, right? So we'll do while this is not equal to 0, right? So as long as this is not equal to 0, we're going to keep looping. Let's see what happens. And we have 10, 8, 6, 4, 2, and then it skips out at 0. Here's what I was talking about before, though. We could see a pretty easy bug introduced into our code. If I were to start my health out at 11, watch what happens. Uh-oh. I have to Control C to get out of that. It was going to go on forever. We had built ourselves an infinite loop. Why, you might say? Well, look, he's in the negatives, certainly, right? Well, yes, he's in the negatives, our character, but the problem is we didn't ask if it was in the negatives. We only stopped our loop while health was not 0. This goes from being 1 directly to being -1. It's never 0. So we never get to skip out of our loop here to finish our program, and we're in an infinite loop. And that's what an infinite loop is. An infinite loop is anytime our condition is continuing to be met, right? Constantly. It's never 0, it's never 0, it's never 0, right? We're constantly meeting that condition. Then the loop's just going to keep going and going and going, and it's never just going to skip out. In fact, some people will even set up infinite loops intentionally, using something like while true, and then if health is less than 0, break. This is not good coding practice, okay? I want to say that up front, that this is not a good way of setting this up. There's better logic to be used, but I wanted to show you kind of how this works, right? So while true is an infinite loop, but we can break the loop just like with our for loops by using the break term, right? The break keyword in this conditional here. And so we do end up breaking out, right? Still alive at 11, you still have 9 health, 7 health, 5 health, 3 health, 1 health, and then game over, you have -1 health, right? So we do break out because of this condition and ultimately print this statement. But if we didn't have that statement, we'd be in another infinite loop, because while true just produces an automatic infinite loop. So an important thing to remember is we're going to use while loops when we're waiting for a condition to change, essentially, without any sense really of like how many iterations it's going to take. And we're going to use for when we want to loop over, say, a collection of things or over a range that we know is going to be defined, right? It's going to have a definite beginning and end. That's when our for loops are better than our while loops and vice versa. We have these two things because you're going to come across different problems where one is going to make more sense than the other. So you just want to watch out for that. When is a while loop going to make more sense than a for loop and vice versa? We can also nest loops. So let's say, for example, we had talked about lists before, right? So let's say we had a 2-dimensional list, or even a 1-dimensional list. Let's do a 1-dimensional list. We'll call it numbers. And we have 1, 2, 4, 5, 6, 7, 5, 7, 8, 9. And let's say we wanted to write a program that found the first pair that our list had in common, meaning the first time it repeated. So what we would do is say for number in nums, setting up our for loop, first for loop, that's going to take each number. And now let's say we wanted to compare that number to each other number. We would write for number compare in nums if number equal number compare print number. So theoretically, this code will start by selecting the number 1 as the first part of the outer loop, and then it will compare number 1 to number 1, compare number 1 to number 2, compare number 1 to number 4. Now we're going to run into a problem because it's going to compare number 1 to number 1 in this first loop here, which we don't want that. So we need to like skip over that first whatever number this is. We want to skip over it. Instead of doing member, we could do an iterator like I and use that to sort of say like, okay, don't do the same I in both places. Or we could use I think it's dot enumerated. Is that right? Let me see. Or indexed. I'd have to look that up. Here's a good example of something where like I'm not entirely clear. I don't remember exactly what the syntax is, so let's look it up. Let's jump back into our browser here. Exit out of this, and let's say for loop enumerated Python. Okay, it is enumerate, it looks like. Let's just double check to see what the syntax actually is. So often when dealing with iterators, enumerate the iterable and the start. Let's see if there's another example of what I'm looking for. That's an enumerate function. I was wondering, I thought, let's see, for loop, what if I want index, for loop, index and value, Python. Might be another way of looking for it. Index and, so you'll notice like I didn't find the thing I wanted initially, so I have to kind of keep looking. Stack Overflow is a really good resource. Sometimes it's hard to understand, but it's good to look at. Let's just see. How do I access the all right, it is enumerate. It's like this. It looks like this. Enumerate the list, and then it will return the index and the value. Okay, cool. And again, that might be a hard thing for you to look at and read without a lot of practice. It takes a lot of practice to be able to look at things like Stack Overflow and being like, oh, okay, that makes sense. Okay, so it does say enumerate nums, which means we're going to get two values here. We're actually going to get an index and a number. And we can do that twice. This, by the way, is not the most efficient way to solve this problem, as we say many, many times. But it is pretty close to what you would consider the naive solution to solving a problem like this. Okay, so now we're going to get both, let's say, index compare, because we don't want the same. So we're going to say if the number equals the number and index does not equal index compare. So now we're saying, okay, I should explain a little bit what's going on here. Let me just pause for a second and explain this syntax. You've seen us assign variables with values by using this comma feature. And typically we've done like, if you remember, we did x, y, z equals 5, 10, 15, something like that. You've seen this construction before. This is doing the same thing essentially in a for loop format, because enumerate actually returns two values. It returns the index and it returns the value. So the iterable is the object supporting the iteration, and the other one is the those are the parameters. Where's the return? Object yields pairs containing a count from start, which defaults to 0, and a value yielded by the iterable argument. So it's telling you it returns two things. It returns an index and it returns the object in the list. And that's what we're doing here. We're capturing the index and the object in the list. Okay, without too much more talking, let me see if this works. Oh, and let's just talk about what the logic here is doing. On line 7 here, the logic is essentially saying if the numbers are the same, but the indexes aren't, meaning we're not saying when 1 is compared to 1 again in the first one in the list, but when something like 5 at position 4 is compared to 5 at position 7, right? Is that 7? If those are the same, then we want to return. Okay, enough talking. Let's run it. And you'll see we actually get all of the pairings. 5 and 7 are both doubled, and then it actually prints them again because 5 and 7 are both doubled, right? They're both in there twice, so it compares the first 5 to the second 5, but it also compares the second 5 to the first 5. If we only wanted the least of these, we could in fact break after this nested loop, and we would find out, interesting. Okay, so break is going to break us out of the internal loop, but it's not necessarily going to break us out of the external loop. It's not actually going to break us out of the external loop, and I'm not sure. I wonder. That's another good thing for us to look up. Let's see if there's a break out of nested loops. Stack Overflow, we love it. Let's check it out. See what they say. Yeah, I mean, for the most part, I think they're going to tell you don't use break, which is true. It's not the actually the best. That's not the best way of doing that problem. So, but I do wonder if there's a way of doing it. Oh, interesting. Okay, so we could do an if else, continuing only if the inner loop did not break, and breaking only if the inner loop broke. That's a way of structuring it, but there's no break 2, it doesn't look like. Yeah, there's no break 2, so I mean, we won't go too deep into it, but yeah, there is a way. It seems like it's kind of a hacky way, and there's probably a better solution than doing it this way anyway, so using breaks not our best option. But here you see how nested loops can be used to solve a problem like finding the first repeated number. Okay, so that is nested loops, infinite loops, and while loops.